Hello, it's Valentine from Simplistic, and we're going to take a look at a problem where we're given uh, an equation with a certain equilibrium constant, and we're given another equation, and we're asked to calculate the equilibrium constant. So usually when you have a problem like this, then the equation given to you and the equation you're supposed to use to find out the equilibrium constant for, they're related in some way. And the key is to figure out what's the relationship between these two. So the first thing is to just look at these two and figure out by inspection what is the similarity. So if you look at these two, you can see number one, the first similarity is that this equation is reversed. What that means is that the reactants, the products out here are the reactants in this equation, and the reactants in the top equation are the products in this equation. So they're reversed. That's number one. And number two is once they're reversed, they're actually this equation out here is multiplied with 2. So if you take this equation, you reverse it, and then you multiply it with 2, you get this. So let's go ahead and write this out for each transformation, what happens. So let's reverse the first equation first. So when we reverse it, we get CO2 gas plus CF4 gas, and that gives us 2COF2. Okay, so let's call the first equilibrium constant K1. Now when equations are reversed, then the equilibrium constants actually end up being reciprocals. So what that means is if we say like the equilibrium constant for this one, let's call that K2. K2 is equal to 1 over K1. That's how it works. So whenever you reverse a reaction or an equation, that means the equilibrium constant gets put under 1. Okay, so we're going to have that there, and then the next thing that we want to do is we're going to multiply this equation with 2 across the board. So when we multiply with 2, we get 2CO2 plus 2CF4, which gives us 4COF2. I forgot to put gas on this. All right, so once we have that, now you can see this equation, this equation is identical to this equation, okay? And that is what K prime is. So when equations are multiplied, here's another rule. When equations are multiplied, so this one is multiplied by a factor of 2, that means the equilibrium constant gets raised to that same factor. So K prime for this one is going to be K2 raised to 2, which is equal to, since K2 is equal to 1 over K1, that is equal to 1 over K1 raised to 2. Now we just have to do some math out here. So K1 is given to us, which is 2.2 times 10 to the power 6. So we'll just replace that. So I'm going to go ahead and put that out here. So K prime is equal to 1 over 2.2 times 10 to the power 6 raised to 2. And that, if we simplify that we get 2.1 times 10 to the negative 13. And there you have it. That is the equilibrium constant for this reaction. I hope that made sense. Thank you for watching.